Good morning. We thank the ISMICs for the opportunity to present our data on a completely new anastomotic connector presented by the University Medical Center Utrecht, the Netherlands. Dr. Buisrug and I are registered as co-inventors, and Vascular Connect partly financed the study. So last ISMICs we presented the feasibility of an ELANA connector on large caliber coronary arteries. To target smaller caliber, clinically relevant coronaries, we ameliorated the concept by downsizing the device and making it completely sutureless. So this is a huge step forward. So we assessed in this pilot study the feasibility and healing of this completely new connector in a porcine OPCAP model. So in 5 pigs, we constructed a LITA to LAD via median sternotomy on coronaries of 1.6 millimeters and evaluated the bypass by flow measurements, angiography, and histology. So here's the so-called Trinity clip, which consists of a spring at the back of the device, an upper fork for sutureless mounting of the ITA, and a lower fork for introduction into the coronary. So here's an animated simplification of the procedure. First, the upper fork is introduced into the lumen of the distal ITA by an applicator, which is not shown. Here, the laser is going into the graft, right into the connector, where it's fixated by an external temporary fixation clip. The laser is activated, opens the graft. Then the lower fork is introduced into the lumen of the non-occluded coronary artery. The laser is activated, laser punches an opening into the LAD. Subsequently, the fixation clip is released and the laser catheter is retracted, including the laser punched fragment of the LAD. Now a hemoclip is placed at the distal end of the graft to complete the anastomosis without ischemia. And please note that the connector stays in situ and is not retracted afterwards. So here the results, 3.2 minutes anastomotic construction time. This is including mounting, 100% hemostatic, and all anastomoses were fully painted at follow-up. This is an angio at 5 weeks. 5 weeks histology. This is mid-anastomosis, a transversal section. You can see a patent orifice with streamlining intimal hyperplasia along the full circumference of the anastomosis without any medial necrosis at the compression site. So to conclude, the Trinity clip is feasible in a small caliber porcine OPCAP model. Especially the concept of completely non-occlusive construction without a time constraint related to myocardial ischemia, so no use of shunts or snares, and in addition working in a bloodless surgical field, offers in its simpleness the potential for minimally invasive CABG. The safety and quality of the anastomosis will be further assessed in a preclinical long-term study, as well as in an atherosclerotic model prior to clinical introduction. Thank you for your attention.
Thank you, Dr. Steger. Maybe you can continue with the second presentation, please.
Of course. Okay, thanks again. We would like to thank the ISMICs again for the opportunity to present our very first experience with robot-assisted endoscopic construction of a LITA to LAD facilitated by the Trinity clip, which we performed in cooperation with Dr. Ki from the London Health Sciences Centre, Canada. Same disclosures. So this presentation demonstrates our first experience with endoscopic robot-assisted application of the Trinity clip. In this single case, we wanted to find answers to the following questions. Is the technique feasible? And are further modifications needed for endoscopic application? So in an acute porcine OPCAP model, we constructed a LITA to LAD with the Trinity clip by using the Da Vinci SI system by an inexperienced robotic surgeon. That's me. And after conventional ITA harvesting, we introduced the robotic arms via median sternotomy. We modified a Da Vinci instrument to be able to open and close the Trinity clip and the fixation clip. So let's have a look at our first experience. So first the graft is mounted onto the upper fork of the connector. The distal end is a straightforward maneuver. Here's the laser, which is introduced via the distal end of the graft right into the connector, where it is fixated by a fixation clip. So the fixation clip stabilizes the mounted complex of the laser, the connector, and the graft. Now the laser is activated, and laser punches an opening into the graft. Subsequently, the laser punch fragment of the graft is removed, after which the mounted complex descends towards the stabilized coronary, which is not occluded. The lower fork is opened by the applicator, inserted into the lumen of the LID. The connector is subsequently closed. The connector provides active compression of both vessel walls. So now the laser is activated, laser punches an opening into the coronary. So all went uneventful. However, unfortunately, a failure to completely release the fixation clip resulted in uncontrolled traction onto the ITA, causing a rupture of the anastomosis. So in conclusion, the Trinity clip is feasible in a porcine upcap model in an endoscopic setting, robot-assisted in a single case. However, the mounted laser limited expediency. Therefore, a more flexible laser and an optimized tool for application of the fixation clip are required for full accessibility to all target coronaries and will further optimize the procedure, which has intrinsic potential to facilitate endoscopic, minimally invasive upcap surgery. Thank you for your attention.
Next presentation will be by Dr. Harris, redo coronary bypass via thoracotomy approach.